6 viewers waiting already. Okay. We are live.
Okay, great. Should we start then, Rashbir?
Yeah, maybe with the next screen.
Yeah. Okay, so welcome everyone. This is another webinar. Yeah, we are gonna be talking about virtual commissioning, different PLCs, connecting to different PLCs and so on, how it's done in Simumatik. So welcome everyone. Hi Rashbir, how are you today?
Hi Mikhail, I'm good. How are you today?
Fine. It's been a long week.
Yes.
It's been a long week.
Yeah.
But I think it's gonna be a fun webinar today. So
I'm enjoying a lot and these days I'm also enjoying a lot of content which I'm creating for Simumatik, and I'm exploding it on the internet these days, if you see our LinkedIn channel.
Yeah, it was
so
crazy.
I hope audience are not tonight.
It was crazy. We have new followers. Very, very cool to see that we have new followers. Yeah. So we are happy to create more content. Followers. Yeah, we are gonna be creating more content.
Perfect.
So today, let's focus. We have been talking about using Simumatik to program PLCs, virtual commissioning, and all this stuff. But today we will be very, very, very niche focused webinar to explain that Simumatik actually allows you to not just to communicate to one PLC at a time, several PLCs at a time. It could be different manufacturers using different protocols, and you do that. You can do it in many different ways, but we already have prepared some components which we call the generic PLCs to do that. And we are going to be explaining a little bit what's a generic PLC, because it's actually a component like any other sensor, but it has more stuff inside. So we are gonna be talking about that, about the difference between different generic PLC components we have created, the generic one and the rack one. And after that, we will do very, very simple demos, just to show how these components are used, but not just one at a time. So we are going to use several PLC components in Simumatik and actually show that we can connect them to different PLCs. Let's see how much time we have, because you have prepared some stuff. I have prepared also some stuff. And this is just part one of what we are expecting to be not a set of webinars, but probably having second webinar. I just realized it says Sardiani. Maybe we can fix the name under my camera picture. Yeah.
Okay.
Okay. So let's start talking about virtual PLCs. I hope audio is okay and pictures are clear. So we are gonna check these guys in Simumatik in a moment in the workspace, and even check them in the component editor. But basically, everyone knows that in Simumatik, everything is a component, and you build a system just putting components together, wiring them, and so on. There are a lot of features you can include in a component, and one of them is what we call the communication driver, which allows a component communicate with external software or hardware. And this is basically what we have done with these generic PLCs. Okay, so those are components which have some different number of input and outputs, but internally the key thing here is that they use this communication driver to allow the user to gather data from another software or hardware and put it in a form of electrical ports. Okay, and we already have covered this in other tutorials or webinars, how you make 2D drawings, how you connect sensors to PLC inputs and so on, or different components within each other. So just to mention that there in the PLC libraries or in the public library, there are some components. Two of them are these generic compact PLCs. One of them has 8 digital inputs and 8 digital outputs. Very simple to use, we will see. And the second one, it has 16 input and outputs and 4 analog input and outputs. So we usually recommend them to do very basic stuff, okay? Because they are compact. You just have a component, you have a bunch of input and outputs, just start connecting stuff and playing around. I hear some noise in the background. Is it maybe, I don't know if it's some echo or something.
Do you hear it again?
No, not now.
Okay.
I think it's going well now.
Right.
And then we have this guy. This is what we call the rack PLC. Okay. The difference with this is that actually what we see in the screen are different components. Okay. Actually, these are 5 components plus the rack and module component. Yeah. So this guy is the equivalent to the CPU, we could say. And the others are components that we attach with a special port, we will see, to the main one, the generic rack PLC, so we can expand the number of inputs and outputs, okay? And basically, this component represents any rack PLC, okay, from any manufacturer. And changing some settings, we can go ahead. So, can you see my screen now? Yes.
Yes, I can see the screen.
Yeah, so here we have loaded 2 systems that you have created, Rashbir. They are called the generic PLC test and the Simumatik PLC rack test station. So those are 2 systems, almost identical, but there is something different inside them. Okay, so let's open the cabinets and check this first one. Okay, what we see here is this 16 input, 16 output, and 4 analog input and output component. We see the power supply here. Basically, if we check this component, it has the driver that we can select, and as we can see here in the screen, Simumatik at this moment is supporting a lot of different drivers to communicate with different software and hardware. We can just select here one driver to use it with a different PLC. And then following our tutorials in the Academy, you can learn how you need to do the setup both in the settings in Simumatik, in this component, and in the software that we are going to use. I think we always mention it before, but you can get to the Academy directly from here. We already mentioned in the last webinar, we are working in a new Academy. It's going to be really amazing with all these tutorials, integration tutorials, with really a lot of new material and so on. So there are 2 things that we can mention here. First of all, the user manual has a chapter here where it comes to data model, where we have this communication driver, which explains a little bit the communication driver. And here we can see all the different communication drivers that have been implemented. And let's say, as we will do later, we are going to be working with PLC Sim. Then we can click here and we can see which are the settings that we can use in a communication driver in a component in order to make this component communicate with PLC Sim or Siemens PLC Sim.
Right.
In this case, all this is that it has been done very simplified, just adding a parameter in the component where we can put those variables, a value for these variables that we need to use for the setup. Okay, so later we will be using PLC Sim in my computer. I already did some setup. This is the IP address of that PLC Sim instance, and not much more. Okay, so so in this case, this compact PLC has a lot of variables, and these variables are to map digital inputs and outputs and analog input and outputs to some variables in the PLC. And in this case, we have, as we will see later in the demo, I just saying that the inputs and outputs, I'm going to map them to first byte number 0 and byte numbers 1 from the input memory, and the same for the outputs. Actually, typing known, what you are doing is that basically saying I'm not going to use the analog variables or analog ports in this PLC. So that's let's not map them to anything in the PLC. So summarizing, I'm gonna reset this so we see actually what's gonna happen when I click play. If I set up the driver in this generic PLC, I set up the variables so that driver knows where is that PLC sim instance at this point, because you can have different PLC sim instances as well. Depending the driver, it's gonna be different parameters, but that is something you can read here in the manual, or as I mentioned in the tutorials in the academy. Okay. Once you do that, you set up the mapping for the variables. You, as we did here, you can basically click play, and if everything goes well, the PLC will say, "I'm happy, I'm running," and you can start playing with that. Actually, I think that let's click this button. Oh no, this one. Yeah, you see something is going on. I can move some stuff. We will look at that later. So I got the connection and so on. And again, maybe I missed to say that all this happens because the gateway is connected. Yeah.
So let me ask you a question. Yeah. Everything is running in the cloud, and your system is connected to a PLC sim running on your computer.
Yeah.
Via this gateway. Am I correct?
Yeah. Yeah. Great. So maybe I jumped that step, but I think we mentioned before that if the gateway is not connected, what it means is that the model is kind of isolated. Okay, it can execute the physics engine, it will execute the components, all the connections, but basically you have closed the door to all these components to be able to communicate with external software or hardware. So basically, and if I click play now, we will see that nothing happens here. Okay, this components is not reacting, while as soon as I activate the gateway and I click play, then these components will start trying to communicate, and if they reach a PLC, in this case, they will get the communication done. Okay, so that was the generic one, and that brings us to the second component. Okay, the generic PLC, rack PLC. Okay, and here, as you can see, if I select, depending which element I select, these are different components. Okay, so we have the output card, we have an input card, we have an analog card as well, and here at the end we have this little guy here, which is what we call the rack end module. Yeah, and this is because this component has this. All these components have this rack input and output ports. Okay, this is where the magic happens. So the generic rack PLC has an output port, which is a rack. It's a serial port. So this kind of port. We haven't talked much about those in previous webinars, but those ports are special because they can send telegrams or they can send information between components. We have been playing with electrical, pneumatical, and hydraulic ports before, and we know that you can send voltage and get current, for example, with the electric port. But serial ports can send and receive a telegram or a message. So we have this is just an application of what can be done with these serial ports. Basically,
maybe you can show it in the Maybe you can show it in the 2D drawings. I have the drawing where you can see all these connections in the drawing number 3. Yeah.
Okay, so just go to that's cool. That's exactly visualizing how all the other ports were electrical or are electrical, but these guys are the rack output and rack input ports. And we just came up with a way of emulating PLCs, and in this case rack PLCs, and make the main component of what we call the rack PLC CPU or the main device, use these serial ports to communicate with potential components that are connected to that.
Nice.
Of course, they all need to talk the same language, and this is something that we came up with. Okay, how we will do so the rack PLC component can communicate with other components and gather the information they want from the real PLC, where they will be mapping these input and output variables. If someone is interested on taking a look to that, as you know, in all components in Simumatik, we are not hiding anything. So you can just go here, open the component editor, and take your cup of coffee and take a look to how we have implemented all the behavior here. It's quite documented, but it's something that can help to understand. Again, you can build.
This.
Yeah.
Mm-hmm.
Sorry, go ahead.
So this is the background of this PLC, how this PLC behaves. So people can also alter that and create their own customized PLC, right?
Exactly. Yeah. So I mean that is it will take us an entire webinar to explain how we have implemented. but the beauty is that PLC connectivity is something that has been done using the components. So the same tool that we have used, or that you can use in Simumatik to create a digitize, for example, a sensor or an actuator or these conveyors that we are seeing here. The same tool, what we call the component editor, with using different features, you can make a component which is a PLC, which is so smart that actually can be connected to other components and communicate with them. So this brings huge opportunities to build quite smart components that could communicate between each other in different ways. Okay, I mean, even if here we see the electrical or this serial connection in the drawings, I mean, this is just a logical connection. It could represent a logical connection. It's not a wire necessarily. Okay. So it could represent a wireless communication between components as well. Okay, but maybe we are going somewhere else now. But at the end, basically what we have is a component, which is the main component, and then we can put on close to that and connect through the rack input and outputs other components. All these guys are included. Let me reset this. All these guys are included in a library. We go to public libraries. We have a library for controllers, and this I guess we will find the no, we don't have the generic ones here.
Maybe in PLC rack.
Yeah,
maybe in the
PLC rack. So here. So here we have a lot of input and output. And here we have the PLC rack. If we just check everything, I think if we just search here by generic, this is the rack module. And the other ones, the other two were these two guys. Okay, PLC 16. So you can find them very easily, and again, it's just drag and drop them. Be careful because sometimes we have seen it sometimes that you see here you have 2 extra ports to feed the component. The power. So if you miss that, even if you have the gateway, you click play, this little guy won't even start trying to communicate. Okay, so that's important. Of course, this is something that we have decided to do like that to be more realistic, and actually, if you want, test, for example, what happens if your PLC gets power or something like that. So in this case, the good thing with the rack is that you need more IOs, just add more cards, okay? And the other thing is that a bit more distributed, the parameters are more distributed between the components. So it's when you select the rack, you just need to select the driver as we did before, and then set up the driver. In this case, this guy will be connected to a Raspberry Pi I have here. This one, Raspberry Pi running Codices. So I just type OPC UA and then the IP address of that Raspberry Pi. It's running the runtime. Okay, so it's just the Codices runtime. You can buy it in their store. Just install the Codices or some the operating system for Codices. Most of it can be done, I think, nowadays can be done directly from Codices. So even update the firmware of the Raspberry Pi and the runtime. So yeah, basically that is, and And what we have in this system, maybe just to round it, you have added a few conveyors, or one conveyor in each of the systems, some lamps, we have some sensors, the product entry here, the product exit, and then a linear actuator. Okay, so everything is wired somehow. So using inputs and outputs, we can control this system. So pretty simple, but it's gonna give us the opportunity to show what we want to show now, the different possibility of connecting and so on. What do you think? Should we go deeper in?
You can maybe run the system together and show us what is the interaction. Maybe if you want to show TIA portal.
Yeah. Should I do that first, or you want to go and show your part later?
I can show my system. I can show my part if you want. Then you can continue after that.
Okay.
However you like.
Yeah, I mean, I don't care. Maybe I can do it. I can do it now. Yeah, when I have everything connected and you can take your part. So.
Okay.
So yeah, what I have here, I have a PLC sim, I have TIA portal with some program that you share with me, Raspberry, so I can control that station. Again, left side is configured to use, or this generic PLC, the compact one, is configured to be used in the PLC sim driver, mapping the inputs and outputs to input and output memory. So what has happened here is that there are some variables, I guess, you have defined here in the tag list. They are addressed to the input and output memory. And actually, when you are using Siemens PLCs, both with the S7 protocol that you will be using later and the PLC sim protocol, there is not much you have to do in the project, in the TIA portal project. One thing you have to do is just to disable the cycle, the scan cycle update in the input cards, in the input memory. That is something you have to do. I guess in this case, unless there is no input card defined, we don't have to do anything.
Yeah, you don't need to do that.
Now,
right.
If we will have done the setup for input and output cards, it is important that you disable the cycle time, this scan cycle mechanism, because otherwise it will clean the inputs, even if Simumatik is trying to write. All this again is in the Academy tutorial, so you can follow the instructions.
Lessons on that.
Yeah, you are creating lessons on that. So
I'm creating lessons on that. So this course, Gateway Integration, will be out in a few weeks, and you can have all the instructions how to link with PLC Sim or S7 or OPC Codices, Modbus, everything will be there.
Yeah, and you just need to make sure you have full access, and it's just a few steps here. Where was it? This the PG interface.
Put-get interface.
Put-get interface. What is that? I don't remember. Connection mechanism. This here, connection mechanism. Yeah, this needs to be checked.
Yeah.
So once you have that, just checking this put-get, because it's what we use in both the PLC sim and the S7 protocol. You can just go ahead, start PLC sim, go online, download the project.
Yeah.
Of course, as you have seen, I already downloaded the project before, so everything is up and running here. And basically, what I can show now is that we can go to the program. We can take a look to this main, open the Googles, and let's do this. Let's share this. Click play here, and basically, what we will see is that if I set this. Let me go up. We see that the key activates the first input and stops the conveyor, and then, for example, just showing that if I click these buttons, I can make the linear actuator. Let me see if we can see it like that. I can make the linear actuator move back and forward. Yeah.
Yeah.
So this is let me get back this cabinet. So this was one of them, and the other is Codices. So in Codices, let's go offline. What we have here, Raspberry Pi.
Right.
I'm running everything in the same computer. So we have the app, PLC Sim, TIA Portal, and now Codices. I install, for those that don't know it, from this version, which is 3.5.18, Service Pack 18, you can install very easily tools from here, add-ons, like this Codices thing. So I actually use that tool to search, the Codices target. Just searching, I think I browse here, I type Codices. Let me see. Yeah, and I install a package which I guess now is already installed. So it was very easy, just restart Codices, and after that I was able to select a new device here in the default, from the default list. So we usually you have just these guys, and now I have these two guys too.
Right.
So once you have that, we use OPC UA with usually with Codices. So define some variables, input outputs, a simple configuration, inputs outputs, check them. I map those variables to some memory. Be careful, because with Codices and OPC UA you cannot write in input memory, so that's why I'm using the marks. And once you do that, I just copy the first 3 rows in your code in Siemens, and basically I did the same but in Codices. So we just go online. Now it's not the Codices local runtime, but we are connected to the Raspberry Pi. Actually, we can see here I typed the same IP address here as the one that we have in Simumatik. And again, now we can have here, let's see, open this. Let me see if we can show a little bit both guys running. I think you're gonna show pretty similar later.
Yeah, I'm gonna show the same later.
Yeah, so I guess if I come here now and I do like this, we see that this guy was activated, and now I can do I can wait. I can press the button, and we can move the actuator and so on. So
pretty cool.
Yeah, so basically that shows 2 things. Same components, just exactly the same components, just changing the communication driver and the settings can be used to communicate, to interface different software or hardware. In this case, we are running against hardware, Codices in a Raspberry Pi, Codices runtime in a Raspberry Pi, and then PLC Sim in my local computer. It could be two instances of the same platform, 2 PLC Sim instances, 3, 4 Raspberry Pis. I mean, the limitation, we usually say, is in your logistics. If you want to communicate or run a system control with several PLCs, the main problem you may have is to have all these PLCs connected in a network. And licenses for all of them and all this stuff.
That's true.
We are asked, we have that question many times. What's the limitation of how many PLCs you can connect with Simumatik? It's not that much that we don't have any soft or hardware limitation. I mean, your computer should handle that. But usually
multiple computer can connect.
Yeah,
but multiple computer with individual instance of PLC can connect to one workspace.
Yeah. So again, you can distribute the thing. There are some soft PLCs that can be reached from other computers. So that means that you could have 2-3 computers having different instances of soft PLCs just to run everything cheaper without so much hardware. Because PLCs are expensive, and maybe while you are doing the commissioning, you don't have access to all the PLCs, because maybe you haven't even get them. So this is offers some flexibility, at least. So
Great.
yeah, I think we covered part of it. Now we can jump and show your screen instead. So let's
Yeah.
go and take a look.
Here it is. That's my screen. The same model, the same system, but what I'm going to show in this example is how we can communicate that with a real PLC. So I have S7 1500 on my table, which is connected to Simumatik. And the connection is very simple. I'm using S7 protocol, which is a very basic one. First, I want to show you, if I open my panel here, you will see two PLCs inside.
Okay, so you did a
One.
mod of the system. This is a different one.
Yes, this is a different system, but I just added extra PLC for this example.
Okay,
So
cool.
I have one PLC. You can see one is powered on and one is powered off. So I'm going to show you first how we can run just one PLC. Like you mentioned before, there are two terminals to power up the PLC, so I turned this one off. Now this is connected to my S7 protocol. And if you see here, I have driver type selected, S7 protocol. And that's the IP address of my real PLC. So my real PLC, you can see it's here. That's my S7 1500. That's the IP address. And this is online, and I just give it here. That's it. That's all I have to do. And another thing is I have to define my addresses. So I give here IB0, my inputs, and IB1. So I have 16 inputs and 8 outputs. The other 8 I'm not using. So if I see in my PLC, I have PLC tags. And if I click on show all tags, I should be able to see my tag. IB0 is here, QB0 is here. So I have my tags here and IB1 is here. So we have to make sure we have correct tags defined here for S7 protocol. For OPCUA, this is different. This you can see in the manual in the course. All right, so what happens now if I click play and close this, and I have a tiny program running. If I start my toggle switch, you can see my box running left and right. So we have two photoelectric sensors on the left and the right, and it will just hit there, it comes back.
Cool.
And on the light, you can see it's green because it's running. And if I go to stop, it will go to red.
Cool.
So very simple program, no complexity, but just wanted to show you how easy it is to connect your real PLC and play around in Simumatik. You have a lot of system, a lot of components, you can bring it here. Pneumatics, hydraulics, motor control, sensors. But this is just an example to show how things are working.
Rajbir, in this case, you have the PLC on your table. It's connected to the Ethernet network. And that's the TIA portal with the code and everything. Okay.
That's the TIA portal, and here I have my program in the main block. It's actually very simple. Some FBs, they're running here, and you can see this actuation happening on my background.
Cool.
So it's like super easy to do. Just write a program in TIA portal, download it to your PLC, connect your IP address to Simumatik, and then things are running. And just one thing you have to make sure, like you already mentioned in the last slide, you have to make sure this protection settings, which you have to check in your device configuration. And here, protection and security, you have to make sure you enable permit of put-gate communication. That's the only thing you need to do. Put your tags, and your system is running. All right, now I want to show you if I stop the system. And let's do one thing. I open my panel, and I go to my PLC, this one, and I turn off the power. So here, this is my power positive. I turn it off, and now you will see both PLCs are off. Now I want to run the second PLC. So it's time to do this one. I will select this one. And here I can select the power. So I have a power supply, you can see next to it. So I can just link the positive of this power to this PLC. And now if I go to play, this PLC is running.
Yeah, cool.
Okay, now let's see what is inside this PLC. This PLC has OPCUA, and this OPCUA is running. And now this is connected to my Codices. So I have my same logic in Codices. Here you can see some couple of FBs. And if I go online, now this is running, setup is running. So immediately I switch from Siemens to Codices, and now I can run the same system. So here now linear drive is running right and left, and here you can see a blinking of light because the system is moving. Now, the interesting part, if I give power to my first PLC again, let's go inside again. And this was pause it for a second. And let's select this one. I give the power X1 PLC assembly, power ideal, and positive. And I go play. Now both of my PLCs are running in this case, so I can start this one and you'll see.
It can be that you need to reset the,
reset again and start again. So I can see now both of my systems are running. So the top conveyor is running with my Siemens PLC, which is a real PLC, using S7 protocol, and this linear drive is running via Codices.
Yeah.
So it's super easy and flexible to add multiple PLCs and run your different system.
And there is a detail, maybe, Rajbir, because when I did it, maybe we didn't have much emphasis in that. I was running two different systems, and one system had a PLC which was connected to all the equipment, and the other system had also everything connected to it. But your case is different because you have now one unique system with two PLCs. And the wiring is done, so part or some of the equipment is connected to one PLC. Yeah, that's what I wanted to see.
That's right.
Can you show that? Show that.
So here you have Siemens S7 1500. So let me show you my wiring of my inputs. So these are my inputs. So it has connected first with an emergency button to provide 24 volts to all the inputs. So if I press emergency stop, then all the inputs don't get 24 volts. And if you see, this is the output of these inputs. So this output is going to individual PLCs. So if I click on that, it will make me jump to this PLC. So here you can see that this is my X1, my power supply, and here is my first input. And this is my second input. So what I'm here doing is I'm connecting one button actually to both the inputs.
Yeah.
You can also remove that. So if you see that this one is also connected here.
Yeah.
But the second PLC only have two inputs, and it has two outputs here. 4, 5, and 6. So you can use same inputs. You can connect to multiple PLCs if you want.
If you want,
have to. Just an option. But that's how I'm using two PLCs in my diagram. And one more thing, if you don't know, the viewers, you can connect your wiring in 2D and 3D both ways. You can do it in 2D or 3D. It's up to you. It will reflect in both the situations. Yeah, this was like pretty nice for me, nice experience to connect PLC. And another thing is you can also notice the status of your IOs here, which is a very beautiful part of this behavior in this PLC. Quite realistic. You can see which output is on, which output is off. And this is very good to commission the PLC. First, you want to check the IOs, and then you can check the real operation on your system.
Actually, that shows even more the potential of the component editor. Because, again, that little guy is a component, and all these LEDs, how to switch them, how to visualize, is done there. It's nothing we have hidden or something special Simumatik can do. You can do something similar if you want.
Exactly. And I'm curious to try other protocols. I'm already trying Modbus, which I tried yesterday. And I was communicating the same environment with Delta PLC, Delta 12 SE via Modbus communication. And that was really interesting, very fast as well. Maybe this is something we can show in the next webinar when we are talking about multiple PLCs. So we can talk about maybe TwinCAT and Omeron and
we have
Arduino
Yaskawa. Arduino, that little guy. We got one, and we are struggling a little bit, but let's see if we can make it work with Modbus.
I can show you Delta PLC. I can also show Control X Core, on which I'm working since so many months. I can also connect that to Bosch Rexroth Smart PLC to this Simumatik. So there are many more things to come in the next webinar, I believe.
Yeah. Another thing that we are asked pretty often is that, okay, let's say you have you want to commission several systems at the time, and those systems have each own PLC. It could be different brands, as you know, or the same brand. Let's imagine you have 3 Codices PLCs. Okay, you want to commission. You can, as they have seen in my demo, it's just about loading several systems at the time, and then doing the proper setting in each of the PLCs. So the scalability is that the PLCs, you can have several PLCs in the same system or several PLCs from different systems all together in the workspace. But one of the questions we usually have is, how do I communicate the PLCs between each other? One thing that you can do, if the PLCs are hardwired between them and you use inputs and outputs, you can do it as we have been showing here, connecting an output from a PLC to an input. But that's not the common way. Of course, you can do it, and usually PLCs communicate between each other using like Modbus TCP or other protocols. I mean, that doesn't happen in Simumatik. So if you want to commission that part, you are able to do that. You just need to configure your PLCs so they can communicate with each other. It's just what Simumatik offers you is that all the equipment that these PLCs are controlling in a unique environment, okay? Independently of the brand of the PLC or robot or whatever, because now we are talking about PLCs, but that was just an example where you can connect Simumatik to many other software as well. So and those can play together. I mean, you can have Simumatik connected to different robot controllers, MATLAB Simulink, and maybe you have your own UDP communication protocol to control program you have somewhere else. So everything can be mixed and can play together. So
maybe in the next webinar, next couple of webinars, we can also talk about how to interface with the robot software like UR5, Virtual, URSim, or RobotDK.
Maybe we can take because we are talking a lot about drivers and so on. Maybe can you open just jump to the Academy, even if we already say that a new Academy is coming. We can go to the Academy and show these drivers.
The new Academy or just Academy?
Just Academy.
Okay.
So
here we have.
Go ahead.
So there is a gateway integration chapter inside. You will find a lot of lessons on different drivers. So for example, you have PLC tutorials and robot tutorials with ABB, and then you have integration with Python. You can also code your Python code and connect to Simumatik and simulate the systems. We have BR Automation Studio, another integration. We have Codices integration, which we just see now. ABB Robot Studio integration, RobotDK, Siemens logo, Python for production line. And interesting part is we also can emulate IoT devices. So this you can also do using MQTT. So you can also integrate components with MQTT. You can also define a component with an MQTT behavior, like individual components. And then we have Siemens PLC, we just saw, Fanuc RoboGuide integration, Simit integration, PLC Next. And this is like third-party integration where you can see how you can create your own driver. And we have integration with Arduino, Ellen Bradley, IoT Coffee Machine, very interesting project where you can play around how to program a coffee machine using MQTT. Then we have Delta PLC integration via Modbus TCP/IP, which is on which I'm working right now. And we have ROS2 integration as well, which I haven't checked yet. Maybe you can talk about it. I don't know much about this ROS. What is this ROS?
ROS is an open source or an open platform to program robotics. So it's actually you can program many robots, most of the robots using ROS.
But is it a virtual robot or embedded robots? Or
I mean, you can take a Kuka robot and use ROS to control it. You need to bypass the controller and do some tricks and so on. So it's an open platform. You can build your own automated guided vehicles or whatever. I mean, you can build your own. You could 3D print your robot and then control it with use the ROS controller for inverse kinematics and all this stuff. So. It's a pretty huge library, or I would say it's almost an operating system, basically for robots.
All right, I will try that. I haven't checked ROS before. And then we have Kuka integration, but these are just the integration part of the website. We have more courses Like if I go back, you can see system modeling, how you can build your system, how you can model the components, component editor, how you can create your own components, how you can import your 3D drawing and give a life to it by adding behavior, inputs and outputs to it. And if you are basic, if you're starting Simumatik for the first time, you can go with a getting started course. But in addition to that, there are some learning paths like getting started, using Simumatik with Python, PLC programming with Python. This will have a step-by-step approach how you can integrate your hardware and software with Simumatik. And interesting part is if you go to our new academy, this is called at the moment newacademy.simumatik.com. We are moving all the courses here because here mostly you will see text or GIF-based courses. We are creating video content, and that is what I'm doing most of the time, and moving all the content from here in the video format in our new academy. So here we have 2 courses which are ready to use, and once you complete that, you will also get a certificate. So you can do the Get Started course and System Building course, and the 3rd course is coming very soon. It's on Gateway and Integration, which we just saw today. So
cool.
Feel free to explore the content in the old and new academy.
So I think it was we have been talking at the end about many things, but the main focus was to show that the potential of Simumatik, showing different or connecting to different PLCs even at the same time, different runs and so on, and the scalability of it. Okay, so of course there are tutorials. Some of them are pending. I mean, we have some logos there, Ohm, Ron, Allen Bradley. Maybe not everything is documented, but I mean, for example, Modbus TCP, almost all PLCs support it. And if you cannot figure out how to use it, you can always contact us and ask, okay, how you do the connection with Modbus TCP and Siemens, because it's also possible. So I think it was pretty interesting.
If you have any questions, feel free to comment on the video. We will get back to you by the comment, or if you can also type now, we can also write. We can also answer now.
So do we have comments or something? Maybe we can just, if we don't have comments now, we can just close stop the streaming.
And we can go to the last slide. And any idea about when we're going to do the next webinar? Maybe in the mid of April, so that the viewers knows what's
I think in a couple of weeks, something like that. I think 2-3 weeks we are gonna be making this the next webinar. They can subscribe so they know, they get a notification, I guess, if we are gonna plan
in the
something.
LinkedIn we all so maybe guys, you can sign up for our website, or you can also just like our page on LinkedIn, where you get all the information for the next webinars and new updates, new videos, new integration. Everything is there.
Cool.
So go ahead, like the page, follow us, and we're gonna give you more information very soon.
Good. So thank you again, Rashbir. It was a pleasure as always.
Pleasure as always. See you next time.
Bye bye. Have a nice day. Bye.